Going?
How are you doing tonight?
I'm doing pretty good. How about yourself?
Good. How's school going since you started back up?
Pretty good. Algebra's been going pretty good. I'm a little confused. We've been doing some factoring, and I'm a little confused on how to do these ones.
All right.
So,
What do you got?
okay, the first one's 3x squared plus 3x minus 6.
All right. What have they taught? What method have they taught you? Do they have a name on it? Is it called the California method or the diamond
Yes,
method?
that's exactly what it is, the California method.
I'm sorry, what?
The California method.
California method, okay. What's the first thing I can do here? Is there any greatest common factor? That's always the first question you want to ask when you go to factor a quadratic.
3 would work, right?
Yeah, no, you're right. We can take a 3 out.
Okay.
What's left over?
It'd be 1, right?
No, we're going to divide each of these 3 terms by 3.
Okay.
So what's left over? What is 3x squared divided by 3?
It's going to be 1x squared.
1x squared. Okay. You can't leave that x squared out of there.
Okay.
Okay, what's the middle term? What's 3x divided by 3?
1x.
And what's minus 6 divided by 3?
It'll be negative 2.
Okay. Now we've reduced this from a hard factoring problem to an easy factoring problem, because the only thing we have to factor is this part. And whenever the x squared term has a 1 coefficient, like this, it's quite easy to factor. Ignore the 3 for a moment. We're going to bring it along, but then we're going to take this quadratic and factor it into 2 parts. Now, I'm not terrific with the California method, but I have my own method that works quite well.
Okay.
Okay, so I'm going to show you that method, and then what usually happens is if I have students that understand the California method and know how to do it, then that's fine with me. Feel free to use it.
Okay.
Otherwise, feel free to use the method I'm going to teach you.
Okay.
Not that different, but it's a little different.
Okay.
I personally find the California method very confusing, very complicated, and not the best way to factor.
I do too. It already confused me.
Yeah. So, let's get rid of the 3 for the moment. In other words, let's talk about factoring the following. Let's figure out how to factor it when there's a 1 in front of the x squared. Because if you can figure out how to factor these, this is 90% of the problem. In other words, you don't have to factor it that much when there's a number in front of the x squared. Now, I know this started out with a 3, but we were able to take that 3 out, leaving this behind. And this is what we need to factor. So, there's 4 steps. First step, separate the x squareds. What goes here? What goes here?
Okay.
What 2 things will multiply together to give you x squared?
X.
X and x, right?
Right.
In other words, when I multiply these 2 things back together again, when I use FOIL or ET, whatever you want to use, I'm going to multiply this times that. And that's got to give me that first term.
By the way, Mr. Cowan, the x2 and the x, those are a plus or a minus.
Excuse me.
It's okay.
Okay? Thank you. Okay, step 2. You might want to write these steps down, because I guarantee you once you learn these 4 steps, you'll like this so much better than the California method. Okay, so step 1 is separating the x squareds out. Step 2 is figuring out what the signs are going to be. In other words, what is that sign going to be and what's that sign going to be? And how do we figure that out? What do we look to? We look to the sign on the constant. The constant is 2, right?
Right.
The sign on that constant is negative. Well, the fact that that's negative means what? What do these two signs have to be?
Negative.
If they were both negative, this would be positive.
Oh, so then they both be, one would be negative, one would be positive.
Exactly. That's exactly the next step. We know that we have a positive and a negative. In other words, we have opposite signs. Okay? So that's step 2, figuring out the signs. Step 3 is factors of 2. What are all the factors of 2?
1 and 2.
That's it. That have to do what?
They have to subtract or add to get 1.
They have to subtract because of that negative sign right there. In other words, not add. If that was a plus, then they would have to add to this coefficient. But because it's a negative sign, then the factors have to subtract to the coefficient of the middle term, which is 1, and they do. So it's perfect. In other words, 2 and 1 work. Now, which goes with the plus sign and which goes with the negative sign?
It'll be plus 2 and then minus 1.
The bigger factor, 2 is bigger than 1, always goes with the sign of the middle term. So the 2 goes there, the 1 goes there, we're done. Now bring back the 3 that we had, and there's our answer.
Okay.
Right there. Okay? Now, let's go through that process again. Let me give you another one.
Okay.
Let's factor this. First step
is to take the x2 and distribute it to be x and x.
Second step.
Second step would be figure out if it's a negative, which it is, so it has to be a plus and a minus.
And notice that that plus minus is the same as minus plus. There's no difference.
Okay.
The only thing we know is they have to be different, right?
Right.
All right. So I'll let it be plus minus. Now what? What's the third step?
Factors of 10.
That do what?
That both. Oh.
Do what because of that?
Do what?
They have to subtract to give you this number here.
Okay, that's right.
The reason they have to subtract is because of this negative sign that I've circled. Okay? So what are factors of 10 that subtract to 3?
2 and 5.
Where's the 5 go?
5's going to go on the minus.
Exactly. You got it.
Okay.
Okay? One more example, and then we'll go on. Factor this. First step.
Okay. So it's going to be x and x.
Second step.
Both be pluses.
Hold on.
Or minuses.
Pluses or minuses, right? In other words, this plus tells you they have to be the same. That's all it says. If I have 2 minuses, that would produce a plus. If I had two pluses, that would produce a plus. So the only thing I know immediately, I'm looking at this sign, is that the signs have to be the same. To figure out whether they're both pluses or both minuses, I look to the middle term. What are they both going to be?
Minuses.
Exactly. Now, third step. Factors of 10 that do what?
That add or subtract to -7.
Well, it's not add or subtract, it's that.
It's going to be add.
And it's not -7, it's 7.
Oh.
That's all you have to do. Factors of 10 that add to 7, well, that's clearly 5 and 2, and it doesn't matter where the 5 goes or the 2 goes. Now, let's talk about checking our solution. Okay? I don't need to check to make sure that's right. I factored it starting with separating that. So I'm 100% sure that I got that term right. I'm also 100% sure I got that term right. My whole process is based on this constant. So I know that -5 times -2 is +10. The only term that I'm not 100% sure of is the middle term. Well, how do you get the middle term? You get it by multiplying the two inside terms together and the two outside terms together, and then adding them together. Well, that's -5x. This is -2x. Add those two together, you get -7x. That's our middle term. We did it right.
Okay.
All right? That's all there is to factoring, as long as this is a 1. If I make that a 2, or a bigger number that you can't get rid of by factoring out a greatest common factor, it increases the degree of difficulty by about 5. So when we get to those, we'll deal with those. But for the moment, you need to be able to factor these simple ones where it's always x squared. And even though your problem didn't start out that way, it started out with 3x squared, the fact is we were able to remove a 3 rather easily, and then we had the quadratic that's quite easy to do.
Okay.
Okay? All right. What's another one that you have?
Okay, it's 4k squared plus 28k plus 48.
First step.
You would do so like terms, right?
No, you can't. There's no like terms here. They've got a k squared, a k, and a number. So it's already combined like terms. There's no more combining. But remember, we're talking about factoring. So what's the first thing you always look for is there a greatest common factor that you can remove?
4.
That's going to make things a whole lot simpler. What's left behind?
Okay, 4 goes to 28.
What's the first term?
First term.
4k squared divided by 4.
The k squared.
K squared. Is that correct? How do we tell? Multiply 4 by k squared, you get that. That's always a step you want to make. Don't ever write this without doing that in your head. In other words, let's say you came up with k. Well, that clearly isn't right, because 4 times k doesn't equal 4k squared. So once you do that division, make sure you multiply it in order to check it. What's the second term?
Be 12.
It's 28 divided by 4.
6, right? 7.
Is 4 times 7 28k?
No.
So what else do I need here?
That's going to be a 12.
A k.
Okay, my bad. Sorry.
See why?
Yes.
In other words, this times that is 28k, and that's what that term is. Always,
Okay.
you have to make that check, always. What's the last term?
12.
Okay. Now, even though we check term by term, does this times this equal this? Yes, 4k squared plus 28k plus 48. Okay, so we got the hard part down. Now we're down to a quadratic where the lead coefficient is 1. That's what we're looking for.
Okay.
Doesn't mean we can throw away that 4. We still got it, but we're going to break up this quadratic into two things. Step 1?
Step 1 is to take the first number, which is k. So it's be k and k, right?
Yep. Second step.
Second step is to be plus and a plus.
Good. Determine both signs. If you're making a list on the steps to factoring, second step is determine both signs. Not just one, but both. Third step.
Is to find factors of 7, right?
No.
Factors of 12.
Okay, that do what?
That add up to 7.
Okay, good. Add up because of that only.
Okay.
Okay? What are they?
Be 3 and 4. Right?
There's your answer.
4 and 3. The leading.
There's your answer. 3 and 4, 4 and 3 don't matter. Same answer.
Okay.
Okay?
What if it's a negative and a positive?
Well, then it would matter. But since it's both positive, this answer that I've written here is the same as this. K plus 3 times K plus 4. In other words, we have the associative property that holds. If I have A times B, that's equal to B times A, always. It doesn't matter the order I write them in. If one's plus and one's minus, then it definitely matters where I stick these numbers. But what else you got?
Okay, it's going to be 7b squared minus 63b plus 140.
First step.
You would 7 goes into 63 and 140, right?
Yep.
Okay, so then it would be 7.
At this level that you're doing, every one of these problems, this is divisible into these two numbers. So it's something you can almost assume is going to be true. Okay, so that means, in other words, I'm going to end up with a quadratic that just has b squared. So I've got to factor out a 7. What's left?
Okay, 63
Hold on, what's the first term?
Oh, sorry, my bad. It's going to be b squared.
Okay. Second term.
It's going to be minus 9.
9 what?
9b.
Okay, you can't leave off that b. In other words, if I had just written 9, now 7 times minus 9 is minus 63, not minus 63b. Remember that this times this has to be that. So that's always a check. You don't ever want to not do that check, because that instantly tells you whether you've done it correct or not. When I write 9b and I multiply this times that, I get minus 63b. What's the last term?
It's going to be plus 20.
Good. Okay, now we have a more traditional quadratic that we need to factor. Can't forget the 7, it's still there. We're just going to split this quadratic into 2. Okay?
Okay. So, so then you're going to do b and b, and then you're going to do a negative and a negative. Okay, and then for the, so then we're going to do the factors of 20, right?
Factors of 20 that do what?
Oh, add up to 9.
Yes.
Okay. So, you could do 2 and 10. No, you can't do 2 and 10. You could do 4 and 5.
Good. There's your answer. Now tell me
Yeah, this is
tell me this isn't easier than the California method.
Yeah, it's really easier. Because in the California method, they make you, like, change fractions.
I try to avoid learning it because I hate teaching it to kids.
Yeah,
Some students I actually have found that have learned the California method and they're confused by my method. So I try not to impose my method on them. As long as you know how to do it, that's what's important. That's the only thing that's important. It's not the method that you use. There is no correct or incorrect method. There is only a correct answer.
Okay.
Okay? What do you got next?
Okay, 3h squared plus 11h plus 6.
Different. How'd I know it's different immediately? Because I can't divide 3 into 11.
Yeah.
Plus 6?
It's going to be 1.
6 was the last. 6 was the constant?
Yeah.
Okay. So, let's look at this. Now, this type problem is significantly different.
Okay.
Because I'm not going to be able to split it up into h and h.
Right.
What will I split it up into?
Well, you can divide them all into 1, right?
Well, one of these has to be 3h, and one of them has to be h.
Okay.
Notice that when I the only requirement is that when I multiply them back together again, they have to be 3h squared.
Okay.
Okay? What are the signs? Now, first of all, let me state this, that whenever we have a quadratic that starts out factoring this way, changes all of the things that I have told you so far.
Okay.
Okay? Doesn't change step 2. Step 2 is to figure out the signs. What must the signs be?
Plus and plus.
Okay, good. That's a long ways towards the solution. But now I can no longer say factors of 6 that do anything. I can't say factors of 6 that add to 11, because one of those factors is going to multiply this 3h here. So the best thing I can do at this point is trial and error. But that's not any worse than the California method, because the California method has quite a bit of trial and error built into it also. Let's list the factors of 6.
1 and 6. 2 and 3.
That's it. At this point, we want to randomly try the answers. And the first one we're going to start with are the 2 closest factors, always. Why? Because that's the problems they give in the state of Colorado. Typically, when they give you a problem like this, these numbers are always going to be the 2 closest factors, which would be these 2 here. You know what I mean by closest? 2 is closer to 3 than 1 is closer to 6. Okay, now it's just trial and error. I could try 3 here and 2 there. And again, the only term I care about is the middle term. I've already checked to make sure that term's correct, and I know that term is correct, because plus 3 times plus 2 is 6. The middle term is the key. Well, to check the middle term, multiply the 2 insides and the 2 outsides, you get plus 3h, you get plus 6h. Does that produce the correct middle term?
No.
So let's try the reverse. Let's try the 2 there and the 3 over here.
Okay.
Does that produce the correct middle term?
No. Yes, sorry,
Yes,
yes.
it does. That's the answer. That's the way I do these kind of problems. In other words, I don't use the California method. I use what I call kind of a trial and error method.
Okay.
But that's how you do them when when this coefficient is not the same as this coefficient, this is 3, this is 1, then you can't use those rules that you're able to use in the real simple ones.
Okay.
In the simple ones, it's very simple. In these kind of problems, it's a little more difficult, regardless of what method you use. You got another one like that?
Yeah.
Good.
6x squared minus 5x plus 1.
Again, no greatest common factor. That's the first thing I would look for. How are we going to break up that 6x squared? We've got two choices. What are the two choices?
You can do 6 and 1.
Okay.
Or you can do 2 and 3.
Which one am I going to choose to start with?
2 and 3.
Exactly, always. That may not be the right answer. We may have to come back and re-examine it, but that's always where I'm going to start. What are the signs going to be?
It's going to be negative and negative.
Okay. What are factors of 1?
1 and 1.
That's it. No, I don't even have any choices. Does that work?
Yes, it does.
You're done. If it did not work, I would go back and I would try 6x and x.
Okay.
So again, it's a little bit of trial and error, but if you stick with this, always use the two factors that are closest together, it takes you a long way. It's not going to be the correct answer 100% of the time, but 95% of the time it will be, especially in Algebra 1. Okay? What's another one?
3n squared plus 5n minus 2.
Again, no greatest common factor. First step?
Is to do the 3 and 1.
3n and n.
Sorry,
Make sure you include the variable.
Okay.
That's the only choice. There's no other factors of 3. And incidentally, this is never an option. You don't ever want to break it up like that. Even though 3n squared times 1 is 3n squared, you always want to break apart the variable. Okay?
Okay.
Okay. What are the signs?
Would it be a negative and a positive?
Yeah, they're opposite. But because this is a 3 and this is a 1, that is not the same as that. So you have to allow for both. So the way I like to do it is I write plus minus there, and I write minus plus here, and I'm going to basically try all combinations. Well, how many factors are there of 2?
1.
Yeah, 1 and 2. Well, let's just randomly plug it in. 1 and 2 there. Does that work?
It does.
Hold on.
No, it doesn't.
Multiply the insides gives you plus n. Multiply the outsides gives you minus 6n, which gives you a total of minus 5n. So
but it's
it doesn't work, but it's got the right number, just the wrong sign.
Okay.
So how can I solve it? In other words, if I move the 1 down to the minus instead of there, and I move the 2 down to the plus instead of there, now check the middle terms. Now we got minus n plus 6n. That gives me my plus 5n, and that will always be the case. If your first try gives you the right number, wrong sign, then just move it down to the other possible sign. Okay? So again, my thinking is this is still easier than the California method.
It is. It's way easier.
Okay, what else you got?
Okay, it'd be 8g squared minus 10g minus 12.
Is there a greatest common factor?
No, it's not.
Ah, there is. They're all even numbers. Whenever
Oh.
they're all
Oh.
even numbers, you got to be able to divide them by 2 at least.
Right.
What's the greatest common factor?
Would it be 2?
Yeah.
'Cause
Leaving.
Sure. It would be 4G
For what?
squared. 4G squared, right?
Uh-huh.
Okay. And then it would be minus 5G,
Okay.
and then it would be minus 6.
Okay. Now we have a quadratic that does not have a greatest common factor.
Okay.
So now we have to factor it like we've learned how to factor.
Okay.
How am I going to break that 4G squared apart?
It'll be 2G and then 2G.
That's one possibility, and that's where I'm going to start. That isn't necessarily the answer. It could be 4G and G.
And 1. Okay.
Right? Okay.
Right.
What are the signs?
That'd be a minus and a minus.
How do I get a minus 6?
Plus and a minus.
Plus and a minus. Now, because this is the same number as this, plus minus is the same as minus plus.
Okay.
Okay? So I don't need to write both. Now I'm looking for factors of 6. And again, I cannot say factors of 6 that subtract to the number 5. I can't do that because these are not 1s. If those are 1s, both of them, then you can use those rules. But when they're not both 1, then you have to use trial and error. Well, what are factors of 6? 1 and 6,
1 and 6.
2 and 3. Well, let's try the 2 and 3. And I'm just going to try 2 there and 3 there. Does that work?
It does not.
No, because it gives me a plus 4G and a minus 6G. That would be minus 2G. Well, if I try the 3 here and the 2 there, that still doesn't work.
Okay.
So what do I have to do?
Do you have to change the symbols?
I got to go back and change the 4G squared.
To the 4 and the 1.
4 and 1, exactly. In other words, my 2 and 2 did not work. So I'm going to use 4 and 1. Now, since this is a 4 and that's a 1, plus minus is not the same as minus plus, so I have to allow for either way.
Okay.
Now, I'm still going to use 3 and 2 as my starters, even though 6 and 1 might be the answer. Does 3 and 2 work?
No.
Remember, only multiply the insides and the outsides to see if it produces the middle term.
3 and negative 8. Oh, it does.
It does. There's my answer.
Okay.
You kind of seeing how we're doing these?
Yeah,
Okay. Got another one?
I do. Negative 3t squared plus 11t minus 6.
Is there a greatest common factor?
No.
Okay.
So,
Factoring is always much, much easier when that's positive.
okay.
Okay? How do we make that positive?
We can change the symbols and everything.
I can factor out a negative 1.
Oh, okay.
Leaving positive 3t squared minus 11t plus 6, which is exactly what you said. Change the signs on every term. But I can't just change the signs. I have to factor out a -1 in order to do it. Okay, well, that comes down. Now I've got two things. Break up the t's.
So it'll be 3t squared. Oh, yeah. And then just t.
It's not 3t squared. It's 3t times t.
Because
That produces 3t squared. Always remember that when you multiply that back together again, it's got to produce this term.
okay.
What are the signs?
That'll be plus negative negative.
Okay. What are the first factors again? Factors of 6 or
1 and 6.
I'm always going to start with the two factors that are closest together.
Okay, so 2 and 3.
Does that work?
Let's see. -2. Choose 9. No. Wait, it does.
Learn to draw these smiley faces. I actually call this my smiley face technique. Because there's the first smiley face, there's the second smiley face. The first smiley face produces -2t. The second one is 3t times -3, which is -9t. Add those two together, you get -11t. That's our middle term. That's the correct answer.
Okay.
Another one.
Okay, -4c squared plus 19c plus 5.
First step?
Is to see if they go into each other, which they don't.
Right.
So
There's no greatest common factor, but there is a problem. We got a negative sign there. So let's clear that up.
okay, so it to be a -1.
Okay.
Right?
Factor out a -1. What's left behind?
Let's see. It would be a -4 or 4, +4, right?
4c squared. When I factor out a -1, I'm not changing anything but the sign on every term.
Okay. So then it will be a -19c and then -5.
All right. Now we're in position to factor out the quadratic.
Okay.
Where am I going to start?
With doing either 4c and then 1c,
Okay.
or 2c and 2c.
Okay. Normally I would start with 2c and 2c. But I can see that +5 and -1, I'm never going to get up to 19.
Right.
Because at most I can multiply 2 by 5. That gets me to 10. So I can pretty quickly know that it's not going to break up into 2c and 2c. Got to be 4c.
Okay.
Merely because, remember, I've got to get to -19 in the middle.
Right.
So 4c times c is 4c squared. I know the signs are what?
It's going to be a plus and a minus.
Okay, so I'll try minus plus. There's only two factors of 5, 5 and 1. Where do you suppose the 5's got to go? Remember, I got to get to -19c.
On the C side, right?
On the negative sign.
Yeah.
In other words, I need that 5 to be there because I'm going to end up multiplying that -5 times 4c. And that gets me a long way towards -19. It gets me to -20. Well, the other one has to be 1.
And 1 times c is 1c.
Yeah. Does that work?
Yeah, it does.
It does. Plus 1c minus 20c gives you -19c. That's our answer. And when I say that's our answer, I mean including the minus 1. So our answer is this.
Okay.
What else?
Okay. Negative 15w squared minus w plus 28.
First step?
Well, they don't go into each other, so we have to do the negative 1.
Okay.
And then it'll be plus 15w squared. And then it will be plus w, and then a minus 28.
Okay. How are you going to break up 15w squared?
Okay, well, it's going to be negative
No.
and a positive.
No. Because all we're doing is breaking up that right there.
You can do 15 and the 1.
I could do it that way, but that's not the two closest factors.
Okay. Oh, we can do 3 and 5.
That's a better start. I don't know that that's the answer. I should admit that right off the bat, that I'm not sure 5 and 3 is the answer, but it's where I'm going to start.
Okay.
What are the signs?
Would be a negative and a positive.
Okay, and because 5 is different than 3, I have to allow for both.
Okay.
What are the two closest factors of 28? Let's list them. 1,
Okay.
28 and 1.
Okay.
What's the next two?
14 and 2.
Next two?
Would be 4 and 7.
What are the two closest ones?
7 and 4.
All right, let's start there. I'm just going to randomly write it like that.
Okay.
Does that work?
No.
Do the two smiley faces. What goes here?
It's going to be 14.
Plus 7 times 3.
Plus 7 times 3?
Uh-huh.
That'd be, let's see, 21, right?
Plus 21w. And then what's the outside smiley face result in?
Let's see, it's going to be a 5 times 4 is 20. Negative 20w.
Negative 20w. Add those two together. What do you get?
Oh, you get w.
Plus w. That's the answer.
Awesome.
Okay?
I don't have any more.
Okay.
So maybe you can give me a couple.
Yeah, let me get my algebra book here. I can find some. It's kind of hard to make these up, merely because I don't factor that well in my head to be able to make them up. I can make them up when it's just x squared, but whenever I'm dealing with a number, it's better if I look them up in my book. Okay, here I got some. I don't know if these factor or not. We'll look and see.
Okay.
Because the instructions here are, do they factor or not? And if they factor, factor them.
Okay.
You talk.
Okay, so they don't factor into each other, so you have to do a negative 1 before, right?
No, there's no negative sign in front of the x squared. That's the only time you have to do a negative 1, is if there's a negative sign on this coefficient.
Okay, so then you have to do 5x squared and 1.
No, never do it like that.
Right, 5x and 1x.
There you go, 5x and x. In other words, always separate the x's. Never leave one side x squared and the other without an x.
Right.
Okay, what are the signs?
Okay, it would be a negative and a, oh no, yeah, negative, negative.
How many factors of 2 are there?
There's only one factor, which is 1 and 2.
Okay. I'll try it that way. Does that work?
Let's see, 1 and x, and then 2 and 5 is 10. No.
Okay. So let's try the other way. 2 and 1. Does that
Okay,
work?
so that'll be 2 and 5. Yes, it does.
That's the answer.
Okay.
Let me give you another. Again, no necessity to factor out a minus 1 because this is a plus.
Okay.
Is there a greatest common factor number that I can take out?
No.
Okay.
So, would it be 2 and 3?
That's a good starting point. It's not necessarily the answer. The answer could be 6 and 1.
Okay.
We're always going to start here. What
Okay.
are the signs?
It'll be a plus and then negative, right? No, plus and a plus. Negative, negative. My bad. I keep doing that. Sorry.
5 and 1 are my only choices. I'm going to just randomly try that. Does that work?
Let's see. That's negative 10 and negative 3. That does not work.
Okay, let's try 1 and 5. Does that work?
Yeah, no, it does not.
No, it doesn't. Okay, that means we go back to the start and try 6 and 1. You with me?
Yep, I'm here.
We're still going to try 1 and 5. Does that work?
Let's see. 6. No.
No, not even close. Does 5 and 1 work?
No.
Okay, so we've tried all 4 possibilities, right?
Right.
Because 6x squared only had 2 different choices, and 5 only had 1 choice. We've tried all possibilities, and none of them produce that middle term.
Right.
So how would I factor this?
I don't know.
Quadratic formula.
Okay.
You had this?
Not yet.
You haven't had this right here?
No, not yet.
Okay. It's coming. Maybe not for a couple of weeks, but it's coming. In other words, when you have a quadratic that you cannot factor into whole numbers, the solution is that quadratic formula. And you'll learn it. I don't want to get ahead of you. But like I said, I was pulling these problems out of a book, and I didn't know whether it factored or not. So let's try another one. Now, when you have a number in front of the x squared that's like 10, well, that makes it particularly hard. What's hard about this problem is that we have multiple choices here and we have multiple choices here. So this is truly a trial and error. This may be the one place where your California method might work better, but I'm not sure even it would. Where are we going to start?
Okay, well, we can do either 10 and 1, or we can do 2 and 10.
2 and 5.
Or 2 and 5, I'm sorry.
That's what you meant, I know. Always start with the closest ones. What are the signs?
So, negative and negative.
What factors of 6 do I want to use?
Be 2 and 3.
I'm going to try 2 and 3.
Okay.
Does that work?
Let's see. 2 and 5 is 10, and that is 6. No, it does not work.
Switch them. Does this work?
No, it does not. Yeah, it does actually work.
Does
Okay.
actually work. And it's important for you not to make a mistake here, because if you don't know that this works, you're going to have a hard time with these.
Right.
You need to be able to check this to see whether it produces that middle term. Again, I'm not caring about that term. I know that term is correct. I'm not caring about that term. I know that term is correct. The term in
Okay.
question is the middle term. Well, that's minus 15x. That's minus 4x. Add them together, minus 19x. Correct middle term, correct solution.
Okay.
Now, these that I'm giving you are probably going to be harder than anything you're going to get.
Okay.
Just because these are fairly hard. Only because there's multiple factors of 18. I could use 18 and 1, 9 and 2, 6 and 3. There's multiple factors of 14. So I may have to try a lot of trial and error here. There
Okay.
is no greatest common number that I can pull out. There's no number that divides into 18, 9, and 14.
Okay.
Where am I going to start?
You could do 18 and 1,
Or
or you could do 2 and 9.
I'd rather try 2 and 9 for starters.
Okay.
What are the signs going to be?
It's going to be a negative and a positive, right?
Huh? They're going to be opposite. In other words, it's not necessarily negative and positive. It could be positive and negative.
Okay.
And I have to consider both because these coefficients are not the same. This is a 2, this is a 9. So whenever these coefficients are not the same and you decide your signs have to be opposite, you have to allow for both possibilities. It's either going to be plus minus or it's going to be minus plus. What factors of 14 should I start with that I should try?
2 and 7.
Okay, I'll try 7 and 2 just because I know that's not going to be right. Does that work?
Let's see. No.
Does it produce the right number?
Because
if it produced the correct number, 9, but the wrong sign, then all I'd have to do is move the 7 down to there and the 2 down to there, and I'd have the answer. But this doesn't even produce the right number.
Yeah, because sometimes 9 is like 60 something, right?
Yeah, 63. So I'm nowhere close to 9. So I know that there's no point in trying 7 here and 2 there.
Okay.
So the only other possibility other than 14 and 1 is to try the 2 here and the 7 there. Does that work?
Okay, well, 2 9's 18, and 2 and 7's 14. No, it doesn't work.
No, it doesn't.
So, we have the wrong number?
Well, the last thing I do before I go back and change this 2 and 9 is to try 14 and 1. Well,
Okay.
I'm not going to put 14 there because I know 14 times 9 will be way too big. So let's try 1 and 14.
Okay.
Does that work?
Well,
No.
no.
No, it doesn't. So I've tried 2 and 7, all possibilities, and I've tried 14 and 1, all possibilities. So I got to go back and I got to try 18 and 1 here. Okay?
Okay.
Now, let's go back and try 7 and 2 again.
Okay.
Does not work.
Well, no.
Doesn't give me the correct number even.
No.
So I know 7 down here and 2 over here isn't going to work either.
Right.
So let's try 2 and 7. That's not going to work. 7 times 18 is huge.
Can you do 1 and 14?
That's the only other thing I can do. And I'm going to try the 14 there and the 1 there. And that does not give me the correct number. Therefore, I've exhausted all 4 possibilities. In other words, I've tried 9 and 2 and 18 and 1. And I've tried 14 and 1 and 7 and 2. None of those combinations produce a plus 9 in the middle. What does that tell me? That tells me that it does not factor, and I got to use the quadratic formula.
Okay.
And yeah, let's end it there. I'm getting a little ahead of where you're at. Not that that's bad,
Right.
because you're going to get there. In other words, you'll be there next week.
Okay.
But they may not give you problems like this. In other words, they're liable to give you, all the problems they're going to give you are going to factor, since they haven't taught you the quadratic formula yet.
Okay.
If you have a quadratic that does not factor, the last solution of last resort is to use this quadratic formula. And I'll just write it, just so you'll get a little bit of familiarity to it. This is called the quadratic formula. A is this coefficient, B is that coefficient, and C is that coefficient.
We've won that.
You have done this?
Well, we know that the coefficients are A, B, and C.
Okay, so the way I would solve this is minus B is minus 9. Plus or minus the square root. B squared is 81. Minus 4 times A is 18. C is minus 14. All divided by 2 times A, which is 36. There is my solution to that quadratic formula. Very complicated looking, but that's the way you do it.
Okay.
Okay? And just know that when you have a quadratic that you cannot factor with whole numbers, you end up solving it by using this quadratic formula.
Okay.
Okay? It's a good place to end it.
Awesome.
You'll know you're a little bit ahead of things. When
Right.
they start talking about that quadratic formula, you'll know what they're talking about.
Right.
All right, Connor?
Awesome. Thank you very much for your help.
You're welcome. I will talk to you next time.
Okay. Bye-bye.